Hello, and welcome to our presentation on the groundbreaking Alert Pro, the world's first real-time airborne asbestos warning device. My name is Raymond Johnson. I'm the Director of Demand Generation for Concept Controls, and today I'm your host for the presentation. Before I introduce our presenter, I want to ensure everyone takes note of the question and chat option at the bottom right of your screen. This is how you can submit questions throughout the presentation or in the Q&A section at the end. So with that out of the way, I'm thrilled to have with me today the distinguished expert in the field of asbestos management, Mr. Daniel Rushton from Alert Technologies. Daniel is an asbestos professional with a history of working in environmental services. With asbestos being his primary area of expertise, he has worked on hazardous materials and contaminated land applications across many sectors and industries, with major construction and infrastructure projects. We also have with us today Mr. Derek Brown, Vice President of Sales for Eastern Canada at Concept Controls. For any of you who have worked with Derek, you know he and his team are experts when it comes to safety equipment and safety instrumentation, which is why he's here to help us answer any questions you may have in the Q&A section. So without any further ado, let's dive into the Alert Pro, the world's first real-time airborne asbestos warning device. Daniel, over to you.
Thanks, Raymond. Hi, good afternoon, good morning, everybody. Sorry, in the UK, it's slightly later in the day. So today we're going to talk through the Alert Pro and the Pro Connected. So as Raymond says, it's the world's first early detection for asbestos, and then we're providing the data on the back end of those alarms. So hopefully by the end of today, you'll have a better understanding of what the Alert Pro does, what it doesn't do, and what we're trying to achieve by having this device available in Canada and the USA as well. So in today's session, we will go through what the Alert Pro is, how the Alert Pro works, the data that the Alert Pro provides. We'll also then touch on the Alert Pro Connect, which is our newest element of the Alert Pro, the Connect online platform. We'll then go through some real world examples of where you can benefit from managing your asbestos risk with Alert, then some usage cases, and if we have some time, we'll go through a Q&A at the end of today's session. Generally, I like to start with a bit of an overview of asbestos risk and understanding kind of what asbestos is, where the problems occur, and why they occur. What I thought would be better today is maybe run a little poll where actually we can ask the question, how much do you know about asbestos? If everyone comes back and you all know quite a lot about asbestos, we can cut this short. If everybody wants to know more about asbestos, then obviously we can spend more time on the background of asbestos. We can then move into Alert. So what I'll do now is I'll publish a poll. I believe that it should come up for everybody, and you should be able to answer the question. So hopefully that should be on everyone's screen now. Raymond, hopefully you can see that as well. Brilliant. So I can see so far we're on 70% know a lot about asbestos, which is a nice number. We've got sort of 30% now, not very much. So I think generally that's pretty good. So we won't focus too much on what asbestos is and where it comes from. But all I'll say is it's a friable material. It's a mineral that is taken from the ground. When it is airborne, it becomes a high risk to health and safety. You release the airborne fibres. They can then get stuck in the lungs. They can actually cause a number of different issues, mainly mesothelioma and asbestosis. Asbestos was used in around 5,000 different products globally. This is anywhere from waterproofing materials, lagging around beams, fireproofing, but also for your everyday purposes such as fake snow. Also used as a clogging material or brake linings, or used actually sometimes for asbestos fireproof suits. So it was everywhere. As I say, 5,000 products roughly. Globally, it still isn't banned. It's still killing roughly 100,000 people per annum. So now that we're all scared about asbestos, I'll move on to what the Alert Pro is. So the Alert Pro utilizes the paramagnetism of asbestos to identify airborne asbestos in real time. It's the world's first and only real-time asbestos detection. We hold the patent for 20 years for the science that we use. We don't just provide a concentration similar to existing technologies and methods. We provide a timestamp data set that shows you your peaks and troughs over that sampling period. We provide real-time alarms, and we provide a warning system that is earlier, quicker, and will give you that notification in real time. There's minimal training required. I've given it to my little sister who is 7. She could get it sampling within 3 buttons within 5 minutes. We provide more information and more data that is available to you as users. We can capture short-term and sporadic releases of asbestos that traditional monitoring does not currently enable you to catch. And when we're alarming, we're 99% confident in the presence of asbestos. That we only alarm when we're 99% based on a statistical analysis. What I'll do first is I'll show you a very quick video of the Alert Pro in action. This is one of our clients in Germany, so the health and safety standards are nothing to do with us. So don't kind of blame me. But what you'll see is that they will actually peel away a piece of asbestos insulation board from the side of a wall. This will then drop down next to the unit, and you'll see it go from a green flashing LED, which means it's sampling. It'll go to an amber and then to a red with a full-on alarm. So I'll play the video now. I will just slightly go back on that, just so you saw the panel actually fall, because I think the video skipped. Apologies, I think that video slipped, so I wanted to just show you again so you can see the panel actually falling. What you can see in that video is how quickly, how short-term, and how sporadic that asbestos release can be, and we can still detect it. Bearing in mind that when we hit that alarm, we've hit 99% confidence that there is asbestos present. What we'll do now is we'll go through the science behind the unit, how they work, and what they do and what they don't do. Then we'll go on to the usage cases and everything else. So, as I said at the start, we use the reorientation of airborne fibres based on the paramagnetism of those fibres to identify asbestos. So the first stage of this is identifying whether it's a particle or whether it's a fibre that we're actually looking at. So the way in which we do this is drawing air into the unit, which contains those particles and those fibres. The first stage is identifying, is it a fibre or is it a particle? So the way in which we do this is by using light scattering. So a laser is shone through every single fibre and every single particle that comes into the system. So there's up to 600 particles and 600 fibres per second. Each of those fibres and each of those particles creates a very distinct pattern, what we like to term as their thumbprint. So every fibre and every particle that comes in has a laser shone through that fibre and that particle. What we're looking to do is actually identify, is it a fibre or is it a particle? The way we do this is by using a peak to mean ratio test. So what you can see on here, on the left-hand side, is you have an asbestos fibre. You can very, very clearly see a peak and a very, very low mean. The middle, you have a water droplet, and you can see peaks, multiple, and a very much closer mean. The furthest right is a silica dust particle. What you can see is inconsistent peaks and an inconsistent mean as well. So this is the first stage. Is it a fibre or is it a particle? Once we've identified that it is a fibre, we actually then record the angle or the orientation of that fibre at the first laser. So we've identified it's a fibre. We've identified the angle of that fibre at the first laser. We then move on to the second stage. The second stage is actually drawing all of those fibres past a magnetic field. This is where actually what we see is that the asbestos rotates unlike any other material or any other fibre we've identified. There are some other fibres that will rotate, but not to the same parameters as asbestos. So for example, carbon nanotubes, we do see a level of rotation, but not to the same degree as asbestos. So we've identified it's a fiber. We've then drawn it past a magnetic field. We then have a secondary laser, which goes through the exact same fibers as it did at the first. But what we're looking for is that recognition of a change in orientation of those fibers once they pass that magnetic field. Once they pass that magnetic field, we then look at that orientation again, and has it changed from the first laser? If it's changed, we say yes, that's changed and that's rotated. We then record that. Whilst this is all going on, we're running a statistical analysis in the background. This statistical analysis leads 30 total fibers to identify whether there's asbestos content present or not. What we're looking for is the rotation of 7 fibers out of 30 to give you a first warning. What we then need is a second set of 30 fibers with 7 or more rotating to then give you a full alarm and that 99% confidence that asbestos is present. So only when you hit that 99% confidence will you have a full alarm. So that is 2 consecutive tests of 30 fibers with 7 or more rotating in both sets of 30. At that point, you'll then get a full alarm. As you saw in the video, that first warning is where you've had 1 set of 30 fibers with 7 or more rotating. So that's how the unit works. If we've got any questions on actually how the unit works, I'm happy to go through those now, Raymond, or we can move on to the end.
Yes, so if you do have questions throughout the presentation, please do type them in the question box down at the bottom right there. If it makes sense, we will stop and answer questions throughout the presentation, or we can hold them till at the end of the presentation as well. One question that did come in, Daniel, is you did mention that there was other fibers there that would kind of go in but not be exactly kind of like asbestos. Is there any fibers that will give you a false positive? I know you mentioned carbon nanotubes. I don't know if carbon nanotubes and asbestos would be in the same building, but yeah.
So through all testing, through all analysis, through all research with the university and over the last 12 years, we've not identified any fibers in the same environment that rotate to the same levels as asbestos. So there are fibers that do rotate, but the parameters set and calibrated within the units are done so just for asbestos. So when we reach that alarm, we are 99% confident every time we alarm that we are seeing asbestos. So at that point of alarm, we're 99% confident. As you say, carbon nanotubes, having worked in asbestos in the consultancy environment for the last 12 years, I've never come across carbon nanotubes in any of the environments you would find asbestos.
We do have a few other questions here. One of them is, does it take into the account the length of the fiber?
So actually what we're looking at is purely on that rotation. So research recently has shown that there's no safe length of asbestos to be safe. So for us, we're looking for that rotation. Under WHO, obviously, there is a length. So we're not looking at the same fiber definition. We're just identifying, is there rotation? Is it asbestos? Yes or no. We look from anything from 1 micron all the way up to 40 microns.
And I don't know what this means, but you might know what it means. There's a question here, how do RCF respond?
RCF as in...
Not sure. I just didn't know if it was something.
Just trying to find the question.
Dave, you asked that question. If you can clarify it, we'll get back to it later. And then there was another one here. It was, will Alert technology use the same technology to make a carbon nanotube detector as well?
Funny enough, we've been asked about the same technology being used for multiple different types of fiber. So we are continually reviewing where we're going to take this product. At the moment, asbestos is kind of our main bag. We've got plenty of asbestos units to get selling, but actually post asbestos, potentially others, yes.
Okay. And then can you explain what you mean by the rotation again?
Yeah, of course.
Answering the question says, I use PLM to detect asbestos, so I'm just understanding if it's a similar way to do the detecting.
So it's a different. I'm just trying to find the question on PLM.
Yep. From
So what I'm just who asked it? Sorry.
From Amanda, if you're looking at the questions there. Yep.
Can you explain what we mean by rotating again? So what we mean by rotating is at the first laser, we record the angle of that fiber on entry. So at the first laser, what is the angle? We then draw those fibers past that paramagnetic or that magnetic field. And because of the magnesium or the iron content in the asbestos, we actually see them physically rotate. So we record every single orientation. So say we call fiber A, we have fiber A, we look at the angle at the first laser, draw it past the magnetic field. We then see fiber A at the second laser, and we look for the difference in the orientation based on that paramagnetism. We're actually looking for the change in the angle of each of those fibers to detect its asbestos.
Okay. Yeah.
I think there's probably quite a lot of questions here, Raymond. So what I'm going to do, if we can record all the questions and take them back, I think then we'll be putting an email together and emailing the answers to absolutely everybody who wants them. Absolutely no problem with doing that at all.
Yeah. And we'll have time at the end as well. So if we go through some more. But yeah.
Just seen. So Dave Keenan just mentioned the RCFs is the refractory ceramic fibers. So we do see some rotations in wollastonite, for example, and our other RCFs, but it's not to the same degree as asbestos. So the parameters that we set for asbestos have been tested and calibrated for those different fiber types.
Yeah.
If we're happy, Raymond, I'll move on to the data and actually how we provide that data. But I'll get all of these questions answered.
Yes.
And then we'll go back.
Absolutely. I mean, keep sending your questions in. We will have time at the end to go through them. And like Daniel said, if we don't get to all of them, we will respond back in an email after the presentation as well.
I think there's probably about 20 questions already. So I think if we go through all of them now, it will be far too long. So what we have on screen now is actually the data that we provide and the data the units provide. What you have on the left or in the purple is your fibers. In the blue, you have your rotated fibers, or in essence, what we're identifying when we get to that 99% confident as being asbestos. You then have your green, which is your particles. The horizontal red lines are actually the time it takes to hit either the warning or the alarm. So here you can see we have this horizontal bar. This is actually showing you when that sample set of 30 started, and when we hit enough in that sample set of 30 to give you that alarm. So what you can clearly see is where you have a higher level of fibers and a higher concentration of fibers in the air, these alarms are happening far more quickly because there's more fiber to be able to actually analyze, not analyze, but detect and then review under that statistical analysis. What you can see here then is this fiber spike where you have these purple fibers increasing. Within this purple fiber spike, you can see in blue the rotated fibers. We have this warning very, very quickly. We then have two alarms very, very quickly because of that fiber spike. What that's then led to is people actually leaving the area or stopping work. You can then see the fiber levels drop off and they actually flatline here. We then have some element of movement or some element of disturbance that has made those fibers that were airborne become airborne again. We then see another spike and another alarm. They then potentially leave the room or the door is shut. We then have another flatline, another fiber spike leads to another alarm. Again, a drop-off, fiber drop-off, we see another fiber spike, which leads to another alarm. What we're actually looking at here is what I like to call activity-based risk management. You can actually identify the specific time where the asbestos was becoming airborne, and actually then you can identify what activity led to that fiber release. So what we are not trying to do is replace any existing technologies. We are not trying to compete with PCM, PLM, or TEM. We are saying, look, there's an extra line, an extra element of safety here. We can not only detect asbestos in real time, but actually we can give you the peaks and the troughs in those fiber levels over a sampling period. If you combine that with a concentration-based existing result with the traditional monitoring, there is no other asbestos information that you can get where you can help you manage that risk more efficiently or more appropriately. So this is the data that we're providing. We aren't just giving you that one result for the whole of your sampling period. This is one example. So this was a refurbishment site. They were actually removing fireplaces. The next one, So this is actually during asbestos removals within a live enclosure. So what you can see is far more activity. You can see far more fibre levels. You can see actually more warnings and more alarms. So what we're seeing here is actually, this is based on the undertaking of activities within that enclosure. So for asbestos removals organisations, this enables you to actually identify at which stage in the removals process are most fibres being released. Well, if you can identify at which stage most fibres being released, you can actually review your methodologies. You can review how you're removing asbestos and where your highest risk element sits. So actually, if you can understand your asbestos risk in more detail, you can make more informed, data-driven, intelligent decisions that aren't just based on an average over a period of time. You can actually see the specific times and the specific activities that are releasing asbestos fibres, and therefore have a better understanding of how you can reduce that risk to your employees and other third-party stakeholders. This one's actually quite a shocking piece of data. We're trialling in Australia currently. This is from a waste management facility. On the left, what you can see is when the unit was actually just in the offices. So yes, there was rotating fibres in the offices. That led to a warning as they went into the shutdown plant. But as you can see, as soon as the plant started operating, you can see the warnings, you can see the fibre levels, you can see the particle levels and the rotated fibre levels jump up very quickly. So actually what we can identify there is that as soon as that plant is operating, you have a very, very inherent asbestos risk. This is what our data can provide. It gives you that opportunity not to only understand there's asbestos risk, but actually see those peaks and troughs and see them in real time. If you've got asbestos, how do you want to know about it? Do you want to know as soon as you can? Do you want to know as quickly as you can? And actually, do you want to also understand what is causing that release? For me, managing asbestos risk, that's exactly what I want to know. We move on now to the Alert Connect. So what this does is take the alert data and puts on an online platform that can be accessed anywhere globally. The Alert Pro is our first unit and is fantastic, but you download the data onto a memory stick, you then upload it to your computer and you can have access to it on the internet. What the portal does is it means if you're managing a portfolio of properties or you have multiple units, you can access to all of that information in one place at one time. So the Connect portal takes all of the data and makes it available anywhere in the world in real time. You can set up notifications that can send you text messages, email, and also third-party application messages if you have a warning, an alarm, or a fault. You can also manage access to different sets of data. So for example, if you're managing multiple sites with multiple units, you can give certain people or third parties access to data for one unit only, or you can give them access to everything. So in terms of your security controls and your asbestos information controls, you can set that up how you wish and what works best for you. So the functionality on the unit, what you can see here is 3 separate days of data on the same location. So what the portal enables you to do is take data from different sites or the same site across a period of time and run comparisons. Well, actually, if you can identify that over a specific period or a specific day, there was a higher release of asbestos or you led to alarms based on specific activities, well, you can ask the question, what was the activity? Can we remove the activity? Do we need that activity? Well, actually, if we can identify the activity, we can then make better decisions about how we manage that risk. Up to now, if you had a short-term or sporadic release of asbestos, that may go unnoticed with traditional monitoring methods. If you're running a traditional sampling pump over 4 or 5 hours, and you have a 5-minute release of asbestos, is that going to change the average over that sampling period? Possibly not. But that doesn't mean at that point of release, there wasn't a risk from asbestos. So what we're saying is here, look, we can show you the short-term and sporadic release of asbestos that you've never been able to see before. If you've got activities or you've got processes happening for a very short period of time, that doesn't mean they are not releasing asbestos. It means that the average potential is not being impacted over the sampling session. So actually, how often are you undertaking activities that are releasing asbestos, but very, very short-term and sporadically? So you're just not seeing them.
So Daniel?
Yes.
Kind of got 2 questions here. There's a few questions. They all kind of relate around 2 different topics here. So one is, can the unit express as concentration? So a lot of the legislation for asbestos is based on concentration, like you were just explaining. Can this unit do this? And then how do you see this working with existing technologies?
Yeah,
It's
perfect.
two kinds of questions coming in here now. So it's just two different topics.
So at the moment, we are testing and trialing our level of concentration. What we don't want to do is give a concentration level that is not 100% accurate or as accurate as we can be. So at this point in time, we do not provide a concentration. There are a number of fibres that we disregard. There are fibres that potentially we don't count. Therefore, if we provide a concentration, it may not be as accurate. So therefore, we're testing and trialing whether we want to do that. So in the future, we may provide a concentration. What we do provide is a flow rate. We provide the number of fibres, and we provide the length of period of sampling time. So if clients wanted to work out an indicative concentration, the data is there. However, we aren't comfortable yet providing that concentration. So hopefully that gives an answer for the first question. The second question, how do we see this working with the existing technology? 100% side by side. All of the testing and trialing we're doing now is side by side with PCM, but also SEM. So what we're doing is running our units to identify the short-term and sporadic release of asbestos. We're then building a data catalogue of traditional asbestos monitoring results to go alongside that. So as I say, we do not see ourselves as a replacement technology. We are currently not an evidentiary method for asbestos fibre monitoring. But what we see is that extra step in safety, that extra front line. Yes, you can have a real-time alarm, and actually you can understand in more detail when your asbestos is being released and what's causing that release. So I think for us, we are very much a side by side with existing technologies.
Thanks.
No problem. On here, you can see your unit dashboard management. So you can see where your units are, you can see what they're doing, you can see how they're operating and where they've been operating. What that also enables you to do then is then run comparisons and create reports. So any sampling sessions, any alarms, any dates where you're actually running a unit, you can then create a report directly from the portal. So if you're on site, you're doing surveys, you're doing removals, you're managing a site for someone, you can print a report directly out from the portal, which you can then provide to your third-party stakeholders. I move on to notifications. So as I said earlier, you can get real-time notifications from our unit anywhere in the world at any time. Once your user is set up on the portal, you can actually enable them to receive notifications via email, via text message, and by a third-party application. You can do this Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, or Sunday, and you can direct by time, by date as well. So if you want it between 9 o'clock in the morning and 5 o'clock in the evening, you can very easily do this. If you want to actually receive it at all times, that's not a problem also. Having worked in the consultancy environment, one of the biggest issues we had was the right people knowing about asbestos release too late. So actually they would have an exposure, and the right people, the health and safety managers, the occupational hygienists, the surveying consultants wouldn't be made aware of the asbestos release until 2 weeks later. By that point, if you did any air monitoring, there's no reason, because actually the asbestos has already been diluted. So not only are we providing those real-time alarms at the unit, you can actually have those real-time alarms anywhere else in the world. I thought this was a really good example to just give today. This is another waste management facility. This is also in Australia. So what you can see on here is the conveyor belt system, where they actually sift and sort through multiple forms of waste: construction waste, household waste, any other form of waste that they would actually accept at the waste management facility. So the asbestos, the waste comes in on a conveyor belt, and actually it's sifted and sorted within 25 or 30 seconds. So every time this comes in, it's only in the building for 25 to 30 seconds. This is not enough time for traditional average concentration-based methods to actually identify that change. This site has been managing their asbestos risk through PCM for the last 5 years. They've never had any levels of asbestos anywhere near occupational exposure limits. We ran units across the site for 4 days. Every single day we had multiple alarms. What you can see on this one is the first day of testing we were there. As you can see, a warning in the morning. And actually, once we hit the alarm, we never leave 99% confidence of asbestos being in the air. So what we can see on here is every time you have an asbestos release, it leads to an alarm. You can see at the end of the day, we have a higher concentration of alarms because there's a higher level of asbestos in the air. So at no point throughout this day were we not at 99% confidence once that was hit. It's just one example of a site where we're working on where they didn't know there was risk, purely because it's short-term and sporadic.
So just listening and going through this, Daniel, is this kind of the, I guess, the use case for the instrument where you see where traditional measurement would come back as a negative, but this tells you, hey, it wasn't present over the whole period of time, but it was present here during this type of activity or this event?
Yeah, I mean, having worked in consultancy, there's been multiple sites where you have short-term and sporadic activities that may last only 5 minutes. They may last 30 seconds. They may last 10 minutes. But actually, that 10-minute release of asbestos or 5-minute release of asbestos over a 6-hour or an 8-hour sampling session just won't impact the average concentration enough for it to actually be identified. So actually, at that point, you may be having a daily release of asbestos, which is never being seen. So over the weeks, the months, the years, how often does that asbestos have to be exposed for people to be at risk? So what we're saying is, look, just because you're not seeing asbestos release on traditional monitoring doesn't mean it isn't there. There potentially is a short-term sporadic release, which is going completely unnoticed. This could be in boiler rooms. I've got a client in the UK. We put the unit in their boiler room for 2 days, 3 days actually, and we identified that there was alarms both days or 3 days at 12 o'clock every single day. We actually identified that the reason the alarms were going off because the caretaker was going and having his lunch in that boiler room every day at 12 o'clock. So instead of having to remove the asbestos and spend budget removing that asbestos, they simply told the caretaker not to eat his lunch in the boiler room on top of the boiler. So actually what we're doing is saying, look, there may be activities you're not identifying that are releasing asbestos, but removing the asbestos is not the only solution. If you can identify the activities and you can identify what is causing that release, can you remove the activity or do you need to remove the asbestos? What we'll do is we'll move on to some more examples of where we're using the alert units. We probably can't go into all of these in kind of finite detail, but I'll run through them. Possibly once we've done this, Raymond, we'll open the questions up again.
Sure.
If you have a look through the questions while I'm doing this and pick out some pertinent ones, that'd be great. So on here, in terms of usage cases, the first one that I always talk about is leak monitoring. When we're removing asbestos, you have an enclosure. Well, actually, what you don't want to do is have an uncontrolled release of asbestos from within that enclosure. How do you currently monitor for leaks? We use a traditional PCM or membrane filter testing system. What that needs is a minimum period of time to identify that asbestos release. That may be 4 hours, it may be 6, it may be 8. You then have a minimum 45 minutes to count those fibres on a traditional sample. Well, actually, if you've got a leak, do you want to know in real time? Do you want to know straight away? Or do you want to know post-event when that contamination has already spread? The longer that leak happens for, the more the contamination, the higher the risk to the people, the stakeholders, and everyone in that vicinity, but also the higher cost to clean up. So that's the first one. But that also goes for decontamination unit monitoring, but also waste transfer route monitoring. If suddenly your waste transfer route or your decontamination unit is contaminated, you can no longer use that system. The longer it's contaminated for, the worse that situation is. The next one we go on to is activity-based risk management and assessments. We've already touched base on this, but if you can identify a 5-minute process or a 5-minute task that is releasing asbestos, you can then make decisions about how you manage that. With your current traditional sampling methods, if you have a 5-minute task over a 6-hour sampling session, you have no understanding if that 5-minute task is releasing asbestos or if it isn't. Because over that 6 hours, the average it just won't add up. It just won't change. We talk about reassurance monitoring. So in the UK, we do a lot of demolition surveys. We do a lot of refurbishment surveys prior to any intrusive works. Unfortunately, that does not always find all of the asbestos. So actually what a lot of our construction contractors use this for is reassurance to their employees that where they're working is a safe place. One of the examples I have of this is a demolition contractor in Germany. They secured a contract to demolish one end of a building. They started their works, they'd removed all the asbestos, or they thought they had. They started demolition works and heavy machinery was employed. Our unit started going off and actually they had 12 alarms. They couldn't identify where the asbestos was coming from. An analyst came back and said, yes, there's definitely asbestos in the air. Surveyor came back and said, hang on, there's no asbestos here. What they hadn't identified was actually the asbestos on the other side of the building but because of the demolition going on at this end of the building, it was shaking the building and actually rattling and rolling, and the asbestos on the other side of the building was being drawn across. So therefore, had they not had a real-time alarm in situ, they would have no awareness of that high-level risk. And actually, that client was able to earn more money because they also secured the removal of the asbestos at the other end of the building also. So that provides that reassurance. As I say, asbestos surveyors, occupational hygienists will try and find asbestos wherever they feasibly can. Until you demolish a property, you cannot always find all of the asbestos. So that gives you that reassurance that you're working in a safe environment. Another case where we've got clients using this for reassurance is in the NHS in England. So unfortunately, 78% of our hospitals still contain asbestos. We have facilities management teams who are responsible for the running and the management of the maintenance of those sites. One of our clients said, look, Dan, our facilities management contractor will not enter this area because they know it has asbestos in. I said, look, is the asbestos encapsulated? Is it safe? They said, yeah, it is, but they still won't enter. They said, we have to get an analyst or an occupational hygienist on site every time we want to enter the area to do any job. It could be changing a light bulb, it could be changing a screw. They want an analyst on site. Unfortunately, in the UK at the moment, analysts are taking anywhere from 2 days to 4 days to get to site. What that was meaning was to change a light bulb was taking 4 days and then 5 minutes to do the light bulb. Well, actually, what that NHS Trust now does is have one of our units on site at all times. They put it in the area for 10 minutes before the facilities management team have to enter. They run it whilst they then get a clearance. They say, yeah, we're fine to enter. They then run it whilst they're doing the works, and they run it for 10 minutes post-event. What they then have is a real-time understanding of risk for that whole process, and they can also create a report, print that report off that shows your fibre levels within that period of time. So it gives you all of that reassurance that you need. The next one on here is asbestos removals prioritisation. So what we're talking about here is actually the prioritisation of your asbestos removals budget. We may have multiple properties in a property portfolio. You may have a fixed budget that you can spend on the removal of asbestos. Well, how do you prioritise? At the moment, it's based on subjective opinion. So as an asbestos surveyor, I might have a different opinion on which is my highest risk material. That's generally based on location, condition, and perceived risk. Raymond may have a completely different understanding and a completely different view on which of those asbestos products is the highest risk. Well, actually, why not put an alert unit in there, let it run for a period of time, and see if you have warnings, see if you have alarms. You go to the next area, you run it for the same period of time. Do you have warnings? Do you have alarms? Well, actually, if you've got alarms in one area, but no alarms in a second area, it's another piece of data, another intelligent piece of data that can help you make those decisions. At the moment, as I say, it's a subjective opinion. What helps make decisions more efficient and more purposeful is unequivocal data that is shown on the device. I've already mentioned it probably 10 times, short-term and sporadic release of asbestos. There is no other system that will pick up the short-term and sporadic release of asbestos like we can. We can see asbestos within seconds of it being released into the air. If I'm doing anything and I potentially have a risk from asbestos, I want to know as soon as it happens, not post-event. When you go and read a newspaper, do you pick up today's newspaper or do you pick up the one from last week? I'd want today's. It's exactly the same for real-time monitoring. If you've got data from 6 hours ago, does that mean your employees, your staff, your contractors, your third parties have been exposed to asbestos for that 6 hours? If we can tell you it's there in minutes, how much time are you saving? How many lives are you potentially saving? And how much cost are you saving also? Another one here is permit to work schemes. So in the UK and Europe and Australia, I think also in Canada, we have a permit to work scheme, which is where you understand there's an asbestos risk or another hazard to health in a certain area. So actually before entering, you sign your name on a dotted line, say, yes, I'm happy to enter. I sign away my rights. Yep, I'm accepting there is a potential risk. Well, actually at that point, how often do you say, well, is there asbestos in the air? When do you say, how regularly have you done asbestos air tests? Having worked at consultancy, I don't think I ever asked the question before I signed a permit to work scheme. Why? I know how risky asbestos is. Why would I not ask to see the safety, see that the area I'm walking into is safe? Well, with this system, you can put it in there for 10 minutes, run it before anybody enters. You have a real-time understanding of risk. One of the developments we're also doing for the Connect portal is going to be the ability to schedule and run tests remotely. So actually you can sit at a laptop, you can sit at a phone, you can sit at your PC. schedule and run tests remotely. So if you've got a unit in an area that's potentially contaminated, you schedule a test, you run that test. No one has to be in there. No one has to be at risk at that point in time. The last one on here, I promise you, is not the last usage case. There's probably, I don't know, I've probably come across hundreds now. And actually every client we speak to has another one or another idea. The last one on here is asbestos removal technique review. So when you're removing asbestos, there may be 4 different techniques you can use. Well, actually, how do you identify which of those techniques is releasing the most asbestos? Well, currently you'd have to run a traditional asbestos run pump for a minimum of, say, 2 to 4 hours. Well, actually, what that means is if you're doing a 15-minute process, you've got another hour and 3/4, potentially 2 hours, potentially 4 hours, where the results from that release of asbestos based on the removal technique is being diluted. Well, actually, if you can run our system whilst you're doing one technique, review the data, do another technique, review the data. And because you can see those peaks and troughs, you can understand, right, well, actually, this removal technique released this number of fibres. This one released this number of fibres. Well, if you can limit the release of fibres, not only are you reducing the health and safety risk, but actually you're also reducing your program. The more asbestos fibres you release, the longer it's going to take to clean them, the longer it's going to take to make sure that area is safe. That's probably the last one that I've got on there, Raymond. But I think there's loads of questions. So do you want me to go through and pick some, or how do you want to play this?
Yeah, if you can see some there. I've seen a few there that I was going to ask. The question does keep coming up about the types of asbestos that it can detect and possible other false positives, other things that might affect it.
So we work with all forms of asbestos, so serpentine and amosite. We've tested with 6 forms. As I say, we work with all forms of asbestos. When we hit that alarm, we're 99% confident that asbestos is present. So at this point in time, we can't define the different types of asbestos. So we don't know if it's a serpentine or an amosite fibre. We are looking to potentially put in the new detection system, which uses imagery as well, and actually uses photography. And at that point, we would then be able to detect the different forms of asbestos. But at this point in time, we just know it's asbestos when we're alarming.
Another question here that came up was basically, how do you use it? How do you operate the machine?
Really good question. What I'll actually do is go back to the picture. Let me share my screen again. Purely because it's probably easier if I show you. Two seconds. Sorry, this is my fault. I'm having too many screens open.
No? Okay. Hey, Derek, if you're available. Oh, there he goes.
So you can see on my screen, on the front of the unit, we have an LCD display screen. All of the functionality is controlled by this very, very simple screen. If you think about your Nokia 3310, we've tried to kind of keep it as simple as that. So actually to turn the unit on, you hold the power button down. Then it will self-calibrate. So every time you turn the unit on, it runs a series of 6 self-checks and 6 calibration mechanisms. So that's looking at the lasers, making sure they're working properly, looking at the inter-arrival time. So that's making sure the flow rate is consistent, make sure enough battery is working properly, make sure the lasers are aligned, make sure that the repels are actually also in the right place. If any of those 6 self-checks don't work when you turn the unit on, you will not be able to use the unit. So it will say there's a fault on the unit, you need to speak to Concept, and they'll probably speak to us unless they can fix it in Canada. But as I say, we've kept it as simple as possible. I have actually also got, if everyone wants to go through the units in particular, Raymond, we can go through on a separate session, we can go through the LCD display screen. But your guys in Canada have got units as well. So if anyone wants to have a demo or a play around, they can do, no problem at all.
No, absolutely. And then the other question here that I've seen pop up a few times was, what kind of calibration or ongoing maintenance does the instrument need?
So we have a 1 yearly service, so 1 service per annum. At the moment, for the first 2 years of release, that's coming back to the UK. purely because we want to see exactly what's happening. That service includes the replacement of consumable parts, so includes a replacement of the pump if it's needed. There's a HEPA filter inside which captures all of the asbestos and the other fibres. If that needs replacing, we'll replace that on the yearly service. With those HEPA filters, if it clogs before the year, we'll also replace that free of charge. We've never seen a filter clog before that 1 yearly service. So yeah, there's a yearly service. After the first 2 years of release, that will then be taken in-house with Concept in Canada as well.
Okay. I think that kind of answers another question here about cleaning the equipment and different things. I guess taking the instrument out of a contaminated area, the instrument itself is contaminated. Do you guys have best practices about how to manage that and clean the instrument, kind of take it out and move it?
Yeah, we've got some decontamination documentation that we can provide to users. Generally, we say, look, the people using these systems should be aware of their own internal policies about how they manage asbestos risk. But we treat it the same as an H-type vacuum cleaner. So that's what they would use for clearing up asbestos. Basically, you would wet vac the outside, wet tack it down, remove any visible debris, and then we can kind of go from there. What we say is don't open the units inside a dirty environment, remove it from the environment, clean the outside. If you need to clean the inside, open up and then clean it.
Okay. And I have a question here for Derek. If you want to take a look through the questions, Derek can unmute himself. The question is, and it's more from the Concept side, is how much does the unit cost, and is the unit available for rent?
Perfect. Okay. So as Daniel was mentioning, there's two different units. So there's the 1000 series and the 2000 series. Currently, right now, we have the 1000 series available for purchase and rent, and the 2000 series is right now available for purchase, not rent yet, but it will be soon. So for the 1000 series, you're looking at 26,000. This is all Canadian dollars. 26,000 Canadian for the purchase of the unit. And for rental costs, we do a daily, weekly, monthly, which is pretty typical throughout the industry. So for rental, you're $250 a day, $1,000 a week, or $3,000 for the month.
Thanks.
I think when we talk about cost, we always look at value as opposed to the cost. I think the job that I told you about earlier, the demolition contractor, they actually secured another 250,000 euros worth of work because of the alarms going off. The other side of things we see with value is that people are undertaking works more efficiently, more quickly, identifying their asbestos risk more efficiently. So actually, I think when we look at asbestos management, we tend to look at value as opposed to just the direct cost, and actually how it can improve your safety, improve your efficiency of management of that risk as well.
Yeah.
Sorry, Derek, to butt in.
Yeah, no, absolutely. Speaking of that, the other part of the question, I think there's been 2 or 3 questions here as well about, and you've talked a little bit about it, but it's basically background monitoring or final air clearance in an area. So after you've done the asbestos removal, can you use this instrument to kind of verify that?
So as it stands, there is no accreditation and no certification for our unit whatsoever. Because it's a brand new technology and a brand new science and a first in the world, we're working with all of the regulatory bodies, all of the bodies around the world. So HSE in the UK, INRS in France, TNO in the Netherlands, the Asbestos Safety Eradication Agency in Australia, the EPA we're now talking to in the US about how we look at this and where can we take it. At the moment, background reassurance monitoring, absolutely no problem. 4-stage clearance and clearance testing, we're not currently looking to do that purely because we aren't accredited for it. So for me at the moment, we aren't a competitor to using your traditional airborne asbestos pumps or your traditional membrane filters for those clearance testing. But what we can provide you is obviously more data. So if you do fail a test, we can actually show you the environment or the time where those fibres were released. So I think we can work alongside those existing systems, but we wouldn't replace them. I saw a question about the data. And actually about whether we can show the fibre data and the level of, or whether we just show alarms and warnings. So what you can see on here, this is the model and the version that we provide with asbestos competent professionals. So on here, you can not only see your fiber levels in the purple, and that's total fibers, so that can be any fiber type. You can also see the blue, which is your rotated fibers. So when we hit that 99% confidence, that is based on the rotated fibers, which in all essence would be the what we're seeing as the asbestos. So yes, we're actually giving you a fiber count. You can see along here on the Y and X axes, you can see your particle levels, you can see your fiber levels and your rotated levels. On the portal, you can actually zoom in and you can go into 1 second aggregated time periods. So you can see your fiber levels every 1 second, every 1 minute, every 2 minutes, every 5 minutes, up to every half an hour. I haven't done it today, but I have also obviously got a demonstration portal, Raymond, that if anyone wants access to, Derek and the team have got access to that. So if any clients did want access to the portal to have a play around, you can do that as well. And actually the data you can zoom in, as I say, you can literally see your fiber levels from second to second. So for me, there's no better way of understanding that risk than seeing the data in a very, very clear format. There's a lot of questions about concentration. As I say, at the point in time, we don't do concentration. But what you can actually see on here is very, very evidently, when you have a higher fiber release, you have a higher concentration of alarms in a much shorter period of time. So although we're not giving you that concentration figure or the centimeter cubed figure, you can clearly see where you have got higher fiber levels, you do have a higher concentration of alarms and therefore asbestos.
One last question, set of questions here that I don't think we've gotten to, and we're close to our time, if not over, is the working conditions for the instrument. Can it be used outside? Can it be used in high temperature environments, low temperature environments? Does humidity affect it? If it's dusty, is that a concern?
So we have used this in all types of environments. To date, the environments where we are not as efficient is outdoors. When you're outdoors, at the end of the day, for us to alarm, for us to alert, the fibers have to get to the unit. So if you think about in an external environment, there's wind, there's draft, there's everything that's taking the fibers away from the unit. So when we talk about the functionality of the Alert Pro system, it's not necessarily about the size of the area or the location of the unit, it's about the flow of the room. So if you imagine you put this in a huge 500 square meter building, if the air is being drawn towards the units, and actually the fibers are making their way to the units, they will alarm. However, if the fibers are being drawn away from the unit and the unit never sees them, it cannot alarm. So the simplest thing to do is actually what we suggest is running potentially some smoke column tests where actually you can see the rotation of the air in the building. So if you can actually identify where the fibers or where the air is being drawn to, you would then locate the fibers, you would then locate the Pro 1000 or Pro 2000, where the fibers and where the airflow is being taken to. So if you can identify where the fibers are, that's where you're going to have the highest level of results, because it needs to see those fibers to alarm. In terms of humidity, dusty, low temperatures, it's more to do with the battery. So as long as the battery is working, that is the biggest limiting factor. I believe the specification for the battery says that we can work up to 55 degrees. And obviously that doesn't allow for direct sunlight. So for example, we're testing and trialing in the desert in Australia at the moment. We've had no issues with humidity. We've had no issues with dust. The only issue we've had is they had to build a shade barrier to stop direct sunlight going onto the LCD display screen. But all the testing we've done, we've not fallen over just yet. But if you can chuck some more environments at us, we'd love to. We haven't worked in some of the -20s that you guys get. So yeah, that would be the next phase of testing is putting it through its paces in cold.
Yeah. No, I think we've got a lot of questions here. I'm sure we haven't answered all of them. I've tried to paraphrase some of them and group together, but we will go through the questions after the presentation and get back to everybody that asked a question and make sure you get an answer. Like Daniel said, if you are curious in a demo or if you want more information, reach out to Concept Controls. Derek and his team, Berkeley and his team in the West, down in the States, we have Brian and his team down there. Let us know if you're interested. We can happily share more information with you. And like I said, Daniel's been really cooperative. Alert Technology has been a great partner with Concept. So if we need to get on a call with Concept Alert Technologies and yourselves, we'll happily arrange that and kind of get through all your questions. Anything else you want to add? No.
Sorry, there's a couple of questions just about the data.
Sure.
Do you mind if I just present the portal in real time? Because I can actually show exactly what the output looks like, and I think it'll answer some of the questions in kind of one go. Just because they were unsure about the output of the data. So I'm more than happy just to present my screen, just so I think it will give more examples and more information. So if you let me share my screen. Where is it? Here we go. So you can see my screen, Raymond, is that right?
Yeah, I can see your screen.
Cool. Right.
Nope, it went away.
Hopefully you can see it. So what I'll do is I'll actually show the data in real time. So this is the data that you actually get on a sampling system. So this is real testing in a real environment. You can then expand this, and you can actually look at each of the individual items in more detail. So for example, if we want to, we can zoom in. And what you can see here is the data as you would get it off the unit. So this blue line is your rotated fibres. At the moment, this is set, so each of these dots is 2 minutes apart. So you can see in each of these 2-minute aggregated sections, how many particles you've seen, how many fibres you've seen, and how many rotations you've seen. So what we can see at this point of alarm at 11:16, between the point of the sampling session started at 11:08. So what you can then do is see how many fibres and how many particles and how many rotated fibres you see in that period of time. So we've seen that we can see a total of 30 fibres with a minimum of 7 rotating. So between that first alarm, you've got 6 rotations plus 2 rotations out of the 30 fibres in that session. So that shows you exactly what you're seeing. What you can see here is with another spike, you've got 24 fibres and 6 rotations at that point in time. At the same time, you've got 22,773 particles. So what this is showing you is exact details for that period. As I said earlier, you can go down into 1 second aggregation. So this is then giving you 1 second intervals, and you can look at the same level of data, but in 1 second intervals. So if we keep zooming in, you can see what you've got in each second as opposed to over those 2-minute aggregates. At the same time, what you can do is actually you can look at the table of data. So this table of data, you can filter and you can look at, right, well, in that period of time, at 12:18 and 37 seconds, we had 6 fibres with 3 rotations. If we change this aggregate again, you can go to 30 minutes. What we then see is in the 30 minutes at 12:30, we had 139 fibres, of which 23 rotated. There's 25,094 particles. So when we're talking about going into that level of detail that we've never seen for asbestos before, for this whole sampling period between 9:30 and 2, you would have 1 average concentration result. What we're providing you is that real-time understanding, but also that data, and that timestamp view of those peaks and troughs of that asbestos risk. I just thought, Raymond, that was worth kind of giving people an overview of.
Absolutely. Yeah.
I think it gives more detail and more understanding of how we're providing it.
Yeah. And like you said, Derek and the team at Concept Controls actually have access to this portal. So I mean, if somebody wanted to go through this in details, like absolutely get in contact with us. We can set up some time and go through a demo of the portal and share the data, the sample data that we have as well.
Yeah.
Anything else you want to add? I know it's taken up a lot of time. You're calling in from the UK. It's what, 7 o'clock, 8 o'clock over there now?
Just that's fine. I think, to be honest, there's a lot of questions about similar things. I think probably best is that we take all of the questions and then we come back as soon as we can. And at that point, if people then want to have a demonstration, I'm sure Derek's team will be more than happy to set up some demos, some live demos, some in-person demos as well.
Yeah, I'll take all the questions. I'll work with you, Daniel. We can put together kind of an FAQ for the different questions, and we can share it out with everybody that's attended as well.
Yep.
Yeah.
Hey, Raymond, are you going to share out contact information too for just straight sales stuff and things like that?
So everyone will get a copy of the presentation. You should, once the presentation's over, you'll get a copy of the recording. We will send out, like I said, we'll put together an FAQ and send out some contact information. If you guys, if anybody wants to get in touch with Concept Controls, we'll make sure they include contact information so that you can reach out to us.
I just wanted to come back on a quick question from Patrick. So Patrick, the elements of condensation haven't ever been an issue at this point, because actually the areas where condensation may potentially cause a problem are sealed. So the entirety of the unit internally is sealed. It's only the batteries that potentially aren't sealed within that enclosure. So I think the answer for the condensation, it's never been an issue to point. We have done testing in very, very humid, very, very dusty, cold, but wet environments. So for example, in asbestos enclosures, where you're misting, where you're damping throughout the whole of the sampling sessions, we've never had any condensation issues at all. But it's not been in whatever minus degrees where potentially you could have different humidity levels. So we want to do more testing and trialing. We're doing that globally. So if we do find any issues, we'll always be very open and honest with those as well. I think what we always look at is in an industry that hasn't changed for 40 years, is we need integrity and we need credibility. That's why it's taken such a long time to release the product, and actually why we aren't doing concentration straight away. We will not do anything until we know we're doing it correctly.
Yeah, I mean, it's one of the things why we're so excited to be partnered up with Alert Technologies for this. I mean, it's been kind of a stagnant thing for a very long time, and this is super exciting for us and our team, and kind of sharing it up with everybody else. This is something else. So thank you for taking the time and going through that with us today.
Super.
Anything else you want to add before we close it out? Daniel, Derek, anything?
No, just if anyone needs anything, feel free to reach out, and maybe you'll get all that contact information on the FAQ. So that's perfect. Thank you.
Absolutely. Okay. Well, thank you all for joining us. I know we went over our time. Hopefully you found this exciting and interesting. Like I said, if you do have questions, reach out. We will share our information to all those that have attended. And if you have questions, absolutely, we'll be in touch. So thank you, Daniel. Go enjoy your evening. And,
thanks, Daniel.
I'll be talking
Cheers,
to you.
guys. See you soon.
See you guys.